for if you take those classes. But I gave you two that I want to use in this class. One of them is called coins, and one of them is called until all. Until all is for your last exam. So when you get to the question on the exam, it'll say go to your program until all, and then you'll fire that program up and use it. It explains to you how to use it in the exam. I want to show you the coins program right now though, and then I want to use it a little bit to show you why it's useful. Because as you just saw, it got way more confusing when we went from coins to cards. The graphs got bigger, the options got more annoying in certain aspects. Imagine going from cards to dice. Right? Or from dice to the rank of the cards in a deck, of which there are 13. You see, ooh, that kind of hurts thinking about it. Right, but if you want to analyze it, which you should, not necessarily cards or coins, or Legos, we'll get to the point of this whole thing momentarily. If you want to analyze it, you have to be able to generate the data. There's two ways you can generate data. One is to do what you guys just did, which is give you a bunch of cards, give you a bunch of coins, start dealing, start flipping, write them down. The other way is you can use computer simulations, which is what that program is going to do. So everybody fire, I'm going to turn Excel off. So when you said use Excel, you half jokingly, we are going to use Excel, we're going to use the TI to do it for us. Grab, if you will, the program button. So it's right under stat, just push the button that says PRGM. You should see a whole bunch of stuff in there now. The button PRGM, push it. Once. So you hit the program button, hopefully you see all this stuff. That's what I just shared with you guys. Most of this, say it again? Oh, you're very welcome. It's your little things I worked on that seem to work pretty well over time. They get refined. A lot of these are 243. Disk draw, disk fill, just the normal, those are all 243. Goff and sample size calc are 244. But the first and last ones are for you guys in 240, in 105. The very first one is called coins. That's the one I want to play with right now. So grab coins by pressing enter once. Now you can press it again.
Oh yeah, I'll press it again.
Now you can press it again.
L1. Power the figure.
Do we need bars?
Oh.
No, sorry, that's why I'm clearing it right now. So you press coins, it kicks you out to your home screen. Press it again.
Okay,
it asks for how many sides your coin has. Here's where you have to let your mind kind of wander about. Because if you think about it, we just did 4 experiments. 2 of which used coins, 2 of which used cards. But theoretically speaking, the deck of cards, the way we were using it, was really
a 4-sided coin.
A 4-sided coin, wasn't it? Honestly, it was. It was just like having a 4-sided. If you think about it, remember those 4-sided dice you used to have? They're shaped like tetrahedrons, 4 triangles with 1, 2, 3, and 4 on them. That's essentially what you were just doing with that deck of cards by pulling and making note of the suit. Because 1/4 of the deck is hearts, 1/4 is spades, 1/4 is clubs, 1/4 is whatever I forgot to say, diamonds. So it's really a 4-sided coin. So if you will, type 4 into it, if you will. Type 4. And then press enter. Yes, ma'am. Thank you.
L1.
Now what it's doing right now, what it did right now, now yours is probably different than mine. I'm hoping it is anyway. Is it just did all the experiments you guys just did, but it did it automatically. It took 4 trials until we saw a repeat. It doesn't tell you which one it saw, but it kept track of it. I can show you the guts for it if you want to see what the guts are. And it took 18 until all the sides showed. So in other words, it's answering questions 1 and 2 simultaneously for you and giving you data for it right now.
So where it says trials until a repeat and then you have a number to the right, yours says 18, this one has 10.
10! It should be different because guess what's happening behind the scenes? Randomness. Random numbers. Shuffling is happening. We should all have different values. Do this again. Press it again. Press enter. It asks, should I roll again? Should I change the die or am I done? Roll again. Roll again. Press enter again. Right now, it took 3 trials until the repeat and 9 until all sides showed. Randy.
Mine just says 1 of each.
1 of each. Boom. I have written the code in the bottom one, right?
No.
No, it just says
Oh, what? Gotcha. Gotcha. So what that means is, you know how we all figured out the minimum number it takes for each? That's what 1 of each means. So in other words, for the until all sides showed, 1 of each means you got 1 of each of the sides. So 4. That would be a 4 for a 4-sided coin. Does that make sense? Does that make sense?
Yeah.
And until a repeat, well, it wouldn't jump with the repeat. Repeat would just be 2. Is that everybody buying this? Every time you press enter, it gives you a choice to flip the coin again. Here's what I want to do. Press enter again. I want you to run a few experiments right now. It's going to be awesomely surprising how fast this is. Because when you can let computers simulate experiments, they go like that, wickedly fast. Because you just saw, that took us what, 30 seconds to do what it took you guys about a minute and a half to do. It's going to only get faster with each instance. Let's change the die to a 6-sided die. Let's actually use a 6-sided die now. So imagine you're playing a board game with your kids, with your friends, and you're rolling a 6-sided die, and you're analyzing, you know if you roll a 3 right now, and then a 4, you're in jail Monopoly or something like that. Something silly, for example. But let's change it to 6, and then press enter. It took 6 trials until I got a repeat, and then it took 8 until I got all the sides to show. Here's what I want you guys to do. Start keeping a laundry list. Let's do this a few times. Let's keep up for about 5 minutes. Just keep 2 columns. In one of the columns, keep the repeats, and in one of the columns, keep the all sides show. And then right before class ends, we'll collect it all into Excel and take a look at it. Everybody follow what I'm saying? We're doing the exact same thing you just did on your quiz, but this is rolling the die for you. Michelle, what's on your mind? Ask me that question.
I have no idea.
Oh, do you understand what I asked you to do? So in other words, I would have 2 columns. 6, 8. Then I'm going to roll the die again. Here it goes. Then I'd write down under the 6, I write a 5. Under the 8, I write an 11. You're just doing the same experiment you just did, but you're using technology to help you. Fair enough? So just do it. Take 5 minutes right now and just write a bunch of numbers. Write a bunch of these random numbers down. Then we'll collect them. Tim, what's on your mind?
Nothing.
Oh, okay. Take it all. Oh my God! Say it again. So much easier. This is why we like using computers to help us solve problems. This is what they were designed to do. You're looking at it right now. You're looking at it right now. This is beautiful. Yes, I agree, Carrie. Thank you.